Hello there. Thank you for joining me on the session on how to design microservice resources. When we start on microservice architecture, majority of the thought goes into how we will structure our code, how many modules our application may have, and other aspects for product deployment. Instead, we should work on the ground first on how we should design our resources and hence build a better microservice. Today, in this session, we will discuss the Richardson maturity model for REST APIs. This model guides us how we should design the resources. This model has multiple levels, and we will go through each in this session, learn what are they, and which one we should aim for if not the best one. Stay with me till the end of this wonderful session on API resource designing. With all being said, let's get started. Alright, before we jump into the discussion, let me introduce myself. My name is Amardeep Tanwar. I am an IT consultant with over 12 years of experience. My area of interest include application designing and solutioning, CI/CD pipelines. This session is not restricted to any programming language though, but wherever required, I'll be referring to Java and Spring Boot. Let's quickly talk about the world before the APIs. Yes, we had monolithic systems. Working and deployments were on silos. I remember few of my clients still on monolithic, but few started on the microservices architecture. In monolithic, everything is tied to one piece. Yes, it had tiers, but all tied to one application and interdependent. If one component fails, whole of the silo goes down and hence the application, or sometimes application throughput. Yes, we can increase the availability of the application by scaling the silos, but that puts a load on the organization in terms of the cost. That's very costly because you have to put up the silo for each application. Suppose we had an application which takes the request, applies some business validations and logic, and finally interacts with either database or external systems or both. Upon detailed analysis of the application, we found that majority of the requests we received did not go beyond the business layer. The component on load were first the one accepting the request, and the next is the business validation layer. This is the layer which rejected most of the requests and other tiers were almost untouched. Once we have a load on our system, we need to scale, but we can't scale a specific component as it is all tied together. This is one of the major problems of the monolithic systems, scaling on demand. Another issue that we face is if there is a change in the requirement, whole of the application need to go through a overall process. Yes, you guessed it right, because of the high coupling. There are many more disadvantages to monolithic systems, but let's limit this discussion to these, otherwise it can be a never-ending discussion. All of these problems we have discussed are solved by microservice architecture. Let's deep dive into the microservice architecture in a second. Now we will discuss why we should choose microservices architecture. We discussed the issues with monolithic in our previous discussion. This guy helps us solve them. First issue this solves is scalability. Scalability as such is not a problem with monolithic, as the deployable unit has small memory footprint and is very cost effective than spinning up a new silo which hosts monolithic application. Yes, they are maintainable. With small size, it is easy and quick to make a change, and team has a quick turnaround time. Teams working on a microservices is sometimes called a pizza team because it takes 2 or 3 person to finish a pizza and hence a service. As they are in a manageable unit, they are generally called single development units or SDUs. SDUs can be tested quickly as we do not have to run a regression on the whole system, but just a changed component of the SDU. Deployment of the SDUs are quite convenient and takes less time as compared to monolithic. Application matrices, distributed log aggregation and tracing, health check APIs, these are the things which helps us increase the observability of a microservice architecture at a component level. Each SDU is stateless. That means it reacts to a data provided to the component. Caching can be introduced for the components which do not hold transactional data, like a master data or having the countries which do not change over time. REST services support multiple media types like XML, JSON, text, Octstream, and many more. I'll put a reference in future read section for all the supported media types for your future references. It is indeed great to see how we have evolved from monolithic to microservices with all the benefits enhancing throughput and reduced turnaround time. In the previous discussion, we talked about the benefits microservices architecture brings, and now let's dive deep into do's and don'ts. When we start designing a service, we don't start with how we should write the code, which design pattern to use. Instead, we should structure the URL to reach a particular resource. If we want to pull the content of a particular book for a particular author, we should write URL as /authors /author ID /books /book ID instead of just writing /getbooks. We will talk more about such instances as we progress in the discussion. Versioning is a good way to identify if a service is backward compatible. Say we have two versions, V1 and V2. And when we prepare the URL for a service, the URL should start with the version. If we continue with the example, our URL with the version would be like /version /authors /author ID /books. Now we will understand how we should put our services beginning from very basic to advanced levels. Yes, you guessed it right. We have 4 levels to this model, level 0 all the way to level 3. Each level defines the principle which we should follow to design a REST resource. Come with me on the other side of the discussion on levels of Richardson maturity model. This is quite the basic step of designing a service or a resource. This is the starting point of a model which uses HTTP as a transport system for remote invocation. Say we want to pull a list of employees for a particular department. At level 0, we would prepare the URL something like post/get employee for department, and we provide department ID in query parameters. And to add an employee to a department, we'll have post/add employee in query parameters. We'll give department ID, and the body will say name, age, and salary. Another variant of this could be, instead of giving the department ID in the URL, we could have in the body. But here the idea is it is very basic level where we can make a transition from monolithic and start breaking our application and thinking in terms of microservices. This level is closest to SOAP web services. Level 0 may also have same service URL but different body to differentiate the operation. Now we are on the level 1 where we start using the URI properly but not the HTTP methods. Yes, we are improving in this level. Now we start to put our thoughts on how we should map our resources. We put together the URL with noun verbs, with path variables, but still not utilizing the HTTP methods. Let's pull a list of employees for our department and see how we modify the existing ones in this level. Post/departments/department ID/employees/employee ID would be the right approach to get the list of employees for a particular department. In this, we start to use the path variables and noun, which are department and employee. From the URL, we can tell which resource it is mapped to. Same goes for add employee resource, which we had in level 0. Post/departments/department ID/employee. In this way, we are putting a resource or an employee into a department. This level is better than level 0. Here, the resources start to make sense. Level 2. This is whatever we discussed in level 1 plus the usage of HTTP methods and returning data with correct responses. We have quite a many supported HTTP methods, but we will go through the ones which we use most frequently. First is get. This is for pulling the data from a source. It can be cached, bookmarked. Get should not be used when dealing with sensitive data because it is all exposed in the URL, plus it has length restrictions. Post. This is used for sending data to the server, are never cached, can't be bookmarked, and there is no restriction on the data length because the data is sent as a body. Put. It should be used for creating resources on the server. The difference between put and post is put is idempotent. Head. This is most identical to get, but without a response body. Delete. This should be used when we want to delete a resource. Say for example, we want to delete an employee. URL would look something like delete, that is the HTTP method, and the URL would be /departments department ID /employee /employee ID. Options. This describes the communication options for the target resources. From your Angular app, you may have observed the first call to a resource is with HTTP options. Patch. This should be used when we want to update an existing resource on the server. In summary, you can use any HTTP method. It will work if coded that way, but if we follow these principles, we have a services compliant to the pattern which are proven to help build services. We have spoken about the methods. Now let's talk about the response codes. Response codes are the one which provides you more information before we look at the response data. They are classified into 5 classes and we will discuss most frequently used in respective class. 1xx. When we develop a services, we don't see the usage of this class, that is 1xx. This is informative like request is received. 2xx or 200 series. This tells request was successful and we have many classification of this and we will discuss few of them here. 200 OK. This is standard successful HTTP response code. 201 created, 202 accepted, 204 no content. Next class we have 300 series. This class tells client must take an action like 302 the redirect one, or we say 302 found. This tells client it was available but now moved temporarily to a different URL. The response headers will have the URL to point to the resource which is available now at the right path. 400 series. This denotes the client errors. 400, that is bad request. 403, when provided authorization is expired or invalid or don't have the correct permission. In a nutshell, server forbids the execution of the request. 401, unauthorized. This is when authorization is required but we did not provide one. 404, not found. 405, method not available. This comes when we try to hit a resource with get but the actual resource accepts post. 500 series. This is the error code class in which server is aware of some error has occurred. We will discuss two types in this one. 500, some generic error occurred while performing the requested action by the server. 503, this tells server cannot handle the request. In this discussion we had gone through the response codes you will use majority of the time in your development life. Whenever we use put, it should be mapped with 201 response code. Remember, put creates a resource and 201 response code would be the best as it suggests it is created. This calls the end of level 2. Let's talk to the ultimate level of API maturity, that is level 3. Now the final level of API maturity. This level is all about we discussed in the levels before plus the next action on the requested resource. HTOS is hypertext as the engine of application state. This guides us where the new resource can be found. Say for example, we created an employee and the response would have a link to the newly created resource and that tells us the next possible operation associated with the requested operation. We have discussed how we should design our APIs using the level of maturity model, but there are some exceptions to the model. This model doesn't force you that you have to use it by any means. If we come across a resource which we find difficult to map as per the maturity defined by level 1, we tend to deviate from the one we have already understood. For example, setting a performance rating to an employee. The URL could be formed something like put /department/department ID /employees/employee ID /stars. Another could be a resource is a perfect candidate of get, but we don't want to expose the details of the URL by using get. In this case, we use post. Alright, this concludes the Richardson maturity model for REST APIs. I hope you learned something from this discussion and try to implement while you work on your projects. Oh, wait, a couple of things to discuss before we say goodbye. Alright, we have discussed the levels of Richardson maturity model, but there are few things which we should discuss before we say goodbye. When we build our service, we should think from the consumer perspective as well. We may build an awesome API, but it's of no use if the consumer can't use it with ease. We also need to focus on the documentation of the API. Swagger is one of the best things we can use to expose the API, which the consumer can try and understand our API. Many of you may have a question, which level of maturity we should aim for. I would say try for at least level 2, if not 3, because HTOS is nice to have, but not mandatory. But when compared with good practices, it's good to have because it tells your consumers all the possible actions after current action is completed. We should not put any secure information in the URL. If you can't get around, try to use base64 encoding. This calls the end of the discussion. Hope you have some takeaways from this discussion. I've put the links and references in the description of the video, which you can go through them if you're interested in a deep dive. I strongly recommend you go through microservices.io. That's the best place to learn the patterns of a microservices architecture. Thank you for watching till the end. If you like the video, please like and subscribe. This motivates me a lot for putting more content like this or even better. Thank you. Thanks for your time.